Hey there, my name is Mason Bennett. This is my presentation on Uranus and Neptune. Um, Audio quality is going to be kind of loud. I'm sorry about that. I don't really have time to fix it. But yeah, here we go. So Uranus and Neptune are our two most outer planets in the solar system. Uranus is seventh from the sun, and then Neptune is the eighth. And these two are referred to as ice giants because they're composed primarily of hydrogen, helium, water, and then various methane gases. Here's another picture showing kind of their scale in reference to the other planets in the solar system. Moving on to how they were discovered. Uranus was first discovered by Sir William Herschel. This was on March 13th in 1781. This was the first planet to be discovered by telescope, though earlier observers, specifically Galileo, had seen the object but thought it was just a faint star, and that was over 200 years before. Neptune was discovered on September 23rd, 1846 by Johann Gottfried, I believe it's Galilei, based on math, actually, instead of observations. And they had noticed irregularities in the orbit of Uranus and believed that there had to be some other massive figure out in space influencing its motion, which is how they came to discover it. Uranus's tilt, axial tilt, is really unique. It sits around 98 degrees. I believe it's 97.77, meaning that essentially it just rotates on its side relative to the orbit around the sun. And so if you imagine, the sun's here and we all rotate around it this way, Earth, for example, also rotates this way, but Uranus instead is going to be flipped and rotating this way while moving in a circle. There's a few running theories as to why that is. The leading idea is that it may have been the result of some collision with an object long ago that roughly was the size of Earth. But this unique tilt causes Uranus to have basically the most extreme seasons in the entire solar system. For nearly a quarter of each Uranian year, the sun shines directly over each pole, and the other half of the planet is plunged into a dark winter for like 21 years. I mean, it is extreme. Another unique quality about them is their color. That's what everyone associates them with. Neptune is always the blue planet, and this is caused by what they're composed of. Uranus and Neptune are both hydrogen and helium-based planets, as I said before. That makes up a majority of their composition. And then there's a small amount of methane and water in the atmospheres as well. And it's that methane that reflects the blue light that causes the planets to appear blue. And they're both very similar to each other as well. Their compositions and their looks are similar to each other, which is why they're both considered blue planets. Looking at their magnetic fields, I already touched on the axial tilt a bit, but magnetic fields are typically in line with the planet's rotation. But because Uranus's magnetic field is tipped over, the magnetic axis is actually tilted away about 60 degrees, as you can see in the bottom middle of this image. Is almost tilted 60 degrees away from the planet's axis of rotation, which is also offset from the center of the planet by about 1/3 of its radius. It has auroras, like Earth and Jupiter and Saturn do, but because of the lopsided magnetic field, those auroras aren't in line with the poles, kind of like how they are on Earth as well. And then for Neptune, the main axis of Neptune's magnetic field is tipped by about 47 degrees. when compared to the rotational axis. Um, the magnetosphere of Neptune undergoes incredibly wild variations during each rotation because of this alignment. And also just an important note that it is much stronger than Earth's. It's about 27 times more powerful than Earth's magnetic field. And so moving past that, we get into the moon systems. Excuse me. Uranus has 28 known moons. While most of the satellites orbiting other planets take their names from like Greek and Roman mythology, Uranus's moons are unique in that they're all named after Shakespeare characters. All of its inner moons appear to be roughly half water, half ice. The composition of like the outer moons remains unknown, but it's likely that they're just kind of captured asteroids that had gone by and got pulled into the orbit. And then, excuse me, for Neptune, Neptune's largest moon, Triton, or I'm sorry, I got ahead of myself. Neptune has 16 moons. Its largest is Triton, which we're going to talk about more in just a minute. But since Neptune was named for the Roman god of the sea, all of its moons are named for kind of various lesser sea gods and nymphs in Greek mythology. So moving on to Triton, it's a really special case. It was discovered just 17 days after Johann discovered the planet itself by William Lassell. And it's the only large moon in our solar system for any planet that circles its planet in the opposite direction to the planet's rotation, if that makes sense. So that's a retrograde orbit. So prograde, as you can see on the right, is kind of the planet spins clockwise, the moon spins clockwise. Triton is the exception. If the planet is rotating clockwise, it's rotating counterclockwise. Because of that, it's kind of theorized that this may have once been its own object in space, maybe like a Kuiper Belt object that had gotten kind of captured by Neptune's orbit and pulled into it. Because if it was some piece of like debris that had broken off, it would be assumed that it would continue traveling in the same direction. Excuse me. The other thing that makes it so special is you can see the right picture is kind of hard to understand, but Triton's surface features cryovolcanism, which is essentially there are volcanoes on the surface of Triton that shoot ice and methane gas into the air. And that's actually what this right picture is showing you from above. And if you kind of like lean back and look at it, it might be a little bit easier to see. But these are 3 photos taken 45 minutes apart each that show one of the volcanoes erupting. You can kind of see near the top here, there's this odd shape, and that's actually the smoke, the gas rising from the surface. And it's estimated that it went miles into the air. I mean, it's extremely powerful. And this was seen by Voyager 2, which is, I wish there was more to show, but this is the only spacecraft that has ever visited these 2 planets. That's the only mission that's been done there, and it was done in the 80s. It flew by Uranus in 1986 and then Neptune in 1989. And these flybys provided the first close-up images we have of both their planets, their rings, the moons, and it gave astronomers a lot of really valuable information about their atmospheres and the magnetic fields and the characteristics of all the moons like Triton. And so with that, the last thing is I wanted to talk about how the rings of these planets were discovered. This is Uranus's ring system, and it's kind of split into 2. There's 2 groups of rings. There's the inner and outer. And so those listed names on the left side here are the inner rings, and then the outer on the right. And for Neptune, we have this beautiful picture, which was actually just gotten or collected, believe it was 2022. It was very recent, that really showed the definition of those rings. And the names are going kind of top down, left to right, are the innermost rings to the outer, and it even goes beyond that. There's, I believe, like 10 more past this list. And these were discovered using, I believe it's called occultation. It's essentially a technique where the planet or moon passes in front of the background star, and that blocks its light, and that kind of allows the astronomers to detect like the presence of it, and determine like the ring's composition and structure. It's a really interesting topic, and I'm not sure if I linked it in the resources, but some of my resources talk about this and how it's used to do it. And it's really fascinating. But yeah, these were both done using, if I go back, using Voyager 2 back in the 80s. And both planets have kind of dark and narrow rings, which kind of separate them a lot from, let's say, like Saturn, who's, prominent rings. I believe that's all. Yep. So that's my whole presentation on Uranus and Neptune. Thanks.